The overall goal of this procedure is the preparation and the electrochemical application of transition metal single atoms coordinated in graphene vacancies towards selective carbon dioxide reduction in aqueous solutions.
This method can help answer key questions in the electrocatalytic CO2 reduction field about the preparation of catalysts and the determination of product selectivity. The main advantage of this technique is that single atoms can be trapped in graphene vacancies, and transition metal nanoparticles can be tightly surrounded by graphene layers.
To begin the procedure, in a 20 ml scintillation vial, combine 0.5 grams of polyacrylonitrile, 0.5 grams of polyvinyl pyrrolidone, 0.5 grams of nickel 2 hexahydrate, and 0.1 grams of dicyandiamide with 10 milliliters of dimethylformamide. Heat the mixture to 80 degrees Celsius and stir until clear and green. Allow the precursor mixture to cool to room temperature afterwards. Then, mount an 8 cm by 8 cm piece of 0.37 mm thick carbon fiber paper as the collection substrate in a conventional electrospinning apparatus. Drop 5 ml of the precursor mixture into a 5 ml syringe. Equip the syringe with a 19-gauge 2-inch needle as the spinning tip and mount the syringe on a syringe pump. Configure the apparatus for a 15 cm space between the spinning tip and the collector surface. Connect the positive terminal of a power supply to the needle and the negative terminal to the collection substrate. Configure the power